Hey, it's Mrs. Williams. Welcome to Geometry this week. Sorry we had technical difficulties and weren't able to do this live, but we will get it done one way or another. The first thing I wanted to show to start out the class is this video by Yay Math. And as you can see over here, there's a bunch of other ones that he's done. He's just a math teacher that makes recordings. And they're really awesome. There's a lot for geometry. And you can find them if you go to yaymath.org. So just like it says on the screen, yaymath.org. And you'll see some other ones. But you can see right here he has a 306090 recording, and I have the link for it in the slides here as well. But you know, this one we're not going to watch the entire thing. You can see it's 9 minutes long. But I just wanted to give you a preview and give you the resources, and you can watch these just, you know, for extra help with the 45, 4590 and 306090. We are going to talk about that today. So I'll give you a little preview. Here we go.
Video like this too. Imagine if I was guarding a palace like this. What's up? What's up? What is this even for? Imagine you walked around in this. It's like, hey, don't bother me. I can protect myself. Alright. 34. Ow. Okay. Alright, good job. Okay, so let's do this. I'm happy because the 45, 45, 90 triangle, 45, 45 triangle is one of the most important lessons in all of geometry. It's on the SAT a lot. So much so that they give you an example of a 45, 45, 90 at the beginning of every math section, which is pretty interesting that the SAT does that. They're basically saying you have to know this coming in, because if you look at the picture, for example, this is a picture with my crazy glove. Yay, math! Good job.
So you can see that that is definitely entertaining, but you also learn a lot about the 45, 45, 90 triangle, which we will talk about today. And like he pointed out, this is really important. You will hear this a lot, you know, whether you're taking TCAP or if you're past that and you're looking towards ACT, you'll need to know this. So definitely check this video out in the 306090, and then of course if you want to do more, I know we've already done some of this, but you know, you can definitely check out that website and see if there's anything else that you are interested in. Okay, so let's talk about 45, 45, 90 triangles. The picture up here I took from your slides in your course, and this is the typical picture you'll see. And as you notice, it's like it sounds, the 45, 45, 90 come from the angles inside. So you'll have two 45-degree angles and a 90-degree angle. The other thing that you might be, you know, the other information that you might have in your triangle to where you would know that it's a 45, 45 without them putting the 45s in there is if they have this side, the legs, and this side marked as congruent. Because if those are congruent, this is an isosceles triangle. You definitely would have to know that this is a 90-degree angle here. But if you had, let's say you just had the 90-degree angle marked and then these two sides were marked congruent and you didn't have the 45s there, you could still calculate that, right? Because you know, if it's an isosceles triangle, that these base angles are the same. And you know, because this is already 90 degrees, that the other two have to add up to 90. If they're the same, divide that in half to get 45. So that's another, you know, situation where you might not have the angles marked, but where you could figure out that, oh, hey, I have a 45, 45, 90 triangle. Now, the ratio of the sides, and actually if you watch that video that we just got done watching, if you watch it all the way through, he'll show you how they came up with the A, and the square root of 2A. And sometimes you'll see x, square root of 2x. It just represents that these two sides are the same, which we've talked about because this is an isosceles triangle. And whatever this side is, so let's say, you know, this side's 5 and 5, to find the hypotenuse, you just take that 5 and multiply it by the square root of 2. So that's what all that stuff means on each side of the triangle. Now, here's a, it's not so bad. if you know one of the legs. If you don't, if you know the hypotenuse, then you're trying to find one of the legs. So you might have a problem where you just know this number right here. And you don't know either of these other two sides. You're trying to find that, or you're asked to find that. You can do it. What you're going to do, though, and I tried to make a sort of like a flow chart here to make it nice and easy for you. If you have the hypotenuse, but not the sides, not the legs, you're going to follow this arrow. You're going to say, okay, I want to go from the hypotenuse to the side. Oh, that means I'm going to take that number and I'm going to divide it by the square root of 2. And that'll tell me what this side is. Let's say you had one of the sides. You're going to follow this arrow. I'm going to say, okay, I have the side. Now I want to calculate the hypotenuse. What do? I multiply by the square root of 2. So, this is one way to look at it, but this will tell you kind of how to use this. So if this confused you when you were going through the lesson, or if you haven't gotten there and it kind of confuses you, try this method, and this usually will help a little bit, just a different way to look at it. So let's try one of these. It says in a 45, 45, 90 right triangle, the length of the hypotenuse is 15 square root of 2. What is the length of one of the legs? So in this problem, you'll notice that we do not have the side length, we have the hypotenuse. So right here I'm going to mark that we know this is 15 times the square root of 2, and we're asked to find one of these sides. We know they're the same, right? It's an isosceles triangle. So I'm not going to follow this arrow because this is for if you have a side you want to go to the hypotenuse. We have the hypotenuse and we want to get the side length. So this tells me I'm going to take 15 square root of 2 and I'm going to divide it by 2. So I'll do that over here. If my pen doesn't go all crazy on me here. Let's try that again. So we have 15 square root of 2, and we're going to divide that by the square root of 2. Everything here is multiplication and division, so the nice thing is that the square root of 2 will just cancel, and I get 15. If you run into a number where it's not quite so nice, where the square roots don't cancel, if the answers are given in decimal form, then you can plug this in your calculator and find the decimal. If they are given in, let's say for example you saw an answer here that was 15 square root of 2 divided by the square root of 3, you wouldn't have that type of situation for this triangle. But let's just say that you had the radicals left in the answer, then you would want to work the problem out, simplify it down using the radicals. Don't plug it in your calculator. If you need help, refresher on how to simplify radicals, let us know. Most of these, they try to give you fairly nice ones, so I don't think you'll get anything too crazy, but if you do need help with the simplification of it, let us know. So the answer here would be C. All right, 30, 60, 90 triangles, and again, here's that link that I mentioned for that Yay Math, and again, you can go to yaymath.org and find this plus more. Here's the picture that you'll typically see. Oh, and it looks like maybe I cut off part of it. This other side is actually going to be a times the square root of 3. So that's the picture you'll usually see. Now if you notice here, again, the sides or the angles are where the name comes from. 30, 60, 90 triangle means that the angles are 30, 60, and 90. One thing that you definitely want to make sure you know on this triangle are which side is shorter, longer, and then hypotenuse. So if you look at the picture that I have over here, I have a 30-degree angle. If you look across the triangle, that side is going to always be your shorter side. So wherever your 30-degree angle is, it's not necessarily going to be at the top of the triangle all the time. It could be down here. It might be, a mirror image of this, and the 30-degree angle would be over here. So you just look at your triangle. You say, where's the 30-degree angle? I want to find the side opposite that 30-degree angle, and because my 30-degree angle is my smallest angle, my smallest side or my shortest side will be across from that. The 60 is the middle-sized angle, right? So if I look across the triangle from the 60, we call it the longest side. It's the middle side if you're comparing all three sides of the triangle. If you look at the shorter side, this side, and the hypotenuse, and you're trying to rank them in order from smallest to greatest. The side across from the 30 would be smallest. This would be in the middle. The hypotenuse would be last. But what you're wanting, or what, a lot of questions will come up, or what you need in order to be able to use this information on the sides, is you need to remember, okay, I'm just looking for the shortest side and the longest side, or the shortest leg and the longest leg. So it's just those two sides that you're comparing. That's why we say this is the shorter one, this is the longer one, okay, because you're just looking at those two. You're not including the hypotenuse. So if they ask you what's the longest side or the longest leg, it's the one across from the 60-degree angle, okay? Now this picture looks a lot more complicated, right? And it is a little more complicated. If you look at, where'd my mouse go? There we go. If we look at this triangle over here, which is usually how the triangle will look, you'll label the side across from the 30-degree angle as A or X, and then to get the side across from the 60-degree angle, you'll take that number, whatever number is over here, multiply it by the square root of 3. And that's how long the 60-degree side, the side across from the 60-degree angle, will always be. And then to get the hypotenuse, you can always take the side across from 30 and multiply it by 2. So that's what the 2a, a squared root of 3a, that's what those mean. And then again here I broke it down for you. Let's say that you have the shortest side. That's information that they've given you. Well, if you want to find the longer side, then follow this arrow. You're just going to multiply that number by square root of 3. If you have the shortest side and you want to find the hypotenuse, multiply it by 2. So for example, if this was 8, I would say, okay, I'm going to do 8 times the square root of 3, which would just be 8 square root of 3, and that's the longer side, or the side across from the 60-degree angle. And then I would take 8 and multiply it by 2 and get 16, and that's my hypotenuse. Let's say, for example, though, that they don't give you the shortest side. You don't know that. They give you this side over here, the side across from the 60-degree angle. Well, the first thing you want to do is always refer back to your shortest side. It's easiest if you can first get to your shorter side. So that would be the first thing you do. Let's say that this longer side is 9. I would want to take 9 and follow this arrow. This tells me I'm going to divide by the square root of 3, and that would give me my shorter side. So it would just be 9 divided by square root of 3. You can't simplify that anymore. But then you would take that 9 divided by square root of 3, and then follow the red, because now you're going, okay, now that I know my shorter side, I'm going to go find my hypotenuse now. And so I would multiply it by 2, and I would get 18 divided by square root of 3. Okay. The other case would be if you are given the hypotenuse, and you don't know the sides. All you have is the hypotenuse. Well, again, if you will follow this blue arrow, you'll notice that it's getting you back to the shorter side first. That's always your first goal. No matter if you have the longer side or the hypotenuse, always find that shorter side to begin with. And you would just divide by 2. So let's say my hypotenuse was 20. I would divide that by 2. That means my shorter side is 10. And then I would go to find my longer side. And I would follow the red arrow, multiply 10 by square root of 3, just 10 square root of 3, and that's my longer side. So let's try one. The directions here, sorry for all the dings and bells. We want to find the value of x, okay? So if we look at the triangle, the first thing we want to do is we want to make sure we know where our 30-degree angle, 60-degree angle, and 90-degree angle are. Now this one's oriented the same as this. So we have a 90-degree angle, 60-degree angle, and we can figure out then that that has to be the 30-degree angle right up there. Okay. All right, so I do know, because this side is across from 30 degrees, that this is going to be my shorter side, my longest side, and this will be my hypotenuse. My hypotenuse is always across from the right angle. Okay, so now let's take a look at the sides. Now that we've identified where the angles are, let's take a look at our sides and let's say, what do we know? Which side do we have information on? Well, we have the hypotenuse. So remember, your goal, if you have the hypotenuse, is to always find your shorter side first. Now in this problem, that's all we're going to have to find. We're not asked for this longer side over here, so after we find the shorter side, we can stop. But let's say, if the question was, well, what are all three sides of the triangle, we'd have to keep going. But your goal is to always first find that shorter side. So we're just going to take our hypotenuse. We're trying to get back to the shorter side, so we want to follow the blue arrow directions, which tell us to divide by 2. So I'm going to take 8 and divide it by 2, and that's going to give me 4. And so A would be our answer for this problem. Okay, let's try another. This one says, find the values of x and y. Okay, so we are going to, sorry, I added this graphic in here. I realized that wasn't on the screen. We're going to, again, first identify where the 30-degree angle, the 60-degree angle, and the 90-degree angle are. There we go. Pull that down. So here's 30, here's 90. That means this one has to be 60, right? So let's put that on there first, just so that we know clearly where everything's at. That means that this side, the side across from the 30-degree angle, is my shorter side. The side across from the 60 is my longest side. And the side across from the right angle is my hypotenuse. Okay? Alright, so now I'm going to take, I want to find x and y, which are just my longest side and my hypotenuse. And I know my shorter side. So if I know my shorter side, you can go to either one, it doesn't matter. If you have your shorter side, you already have, the most important piece, the easiest piece to have. So if you have your shorter side, just find either, it doesn't matter if you find hypotenuse or longer side first. So we're going to find the longer side, we would multiply by square root of 3. So if I'm going from the shorter side to the longer side, I'm just going to take that value of 5 and multiply it by the square root of 3. And that's as simplified as you can write that. So x is 5 times the square root of 3. And then to find my hypotenuse, it tells me I'm going to multiply by 2. So to get 5, to get to y, I'm going to take 5 and I'm going to multiply it by, oh, sorry, did I say square root of 2? I meant to say just 2. I think I might have said square root of 2, but I'm just going to take 5 times 2. And so y would be 10. 5 times 2 is 10. Okay? And there are your x and your y value, your longest side and your hypotenuse. Okay, let's try another one. I'm going to go grab that picture again. So we have it. All right. There we go. So directions are the same. Again, you want to find the 30, 60, and 90-degree angles just to make sure you know where they are. Oh, again, they're already marked for us, so that's nice. So then identify your sides. Which side is shorter? Which side is longer? Which side is the hypotenuse? This side across from the 30-degree angle is going to be the shorter side. We don't know it, so remember that's going to be our first goal. We're going to try to find that. This side over here, since it's across from the 60-degree angle, is our longest side. And then the angle across from the 90-degree angle is our hypotenuse. Okay? Alright, so the first thing we're going to do is we're going to find our shorter side. The only side that we know is the 15. So I'm going to draw an arrow here. I'm going to try to find that shorter side. So to find that shorter side, let's see what we do. We have the longer side. What are we going to do to get to the shorter side? Divide by square root of 3. So I'm going to take 15 and I'm going to divide it by the square root of 3. Okay, and that actually, as ugly as it looks, is as simplified as you can get that. Remember with square roots, you're looking for, you want to take the number under the square root and factor it down into its prime factors. Well, 3 already is prime, so we can't factor it anymore. But if it was a number that did factor, you would look for pairs, and those pairs will come out of the square root. But since this one is already simplified, we just leave it as 15 divided by square root of 3. Okay, so that's my shorter side. That's my x. So now I have one more thing to find, which is my hypotenuse. So now I'm going from the shorter side to the hypotenuse. So what do? Well, I have my shorter side, and I'm going from the shorter side to the hypotenuse. So this tells me I'm going to multiply it by 2. Okay, so I'm going to take 15 square root of 3, 15 divided by the square root of 3, and multiply it by 2. Well, remember, if you have a fraction, change the other number into a fraction as well, and then you just multiply straight across. So 15 times 2 would give me 30. Square root of 3 times 1 is square root of 3. And so my y value is just going to be 30 divided by the square root of 3. So you don't always get pretty numbers, but that's what they are. And you can double check too. If you want to, you could plug all of these numbers, all three numbers into, because this is the right triangle, you could plug them into the Pythagorean theorem. A squared plus b squared equals c squared, and they should check out. The a squared plus b squared should equal the c squared. So that's, definitely an option if you want to go ahead and check it. All right, so we're going to move on to area of a regular polygon. And here are two great videos by a different a different teacher, but one that's really awesome for geometry. It's Brightstorm. They come from brightstorm.com. Unfortunately, Brightstorm is charging this year to watch their videos, which I am so bummed because the geometry ones are awesome. But you can find a few of them on YouTube, like I have here, that are free still. So check out these videos. One of these is really awesome. You'll see this formula here that we're going to go over. He shows you a different way to think about the formula in terms of triangles, and so it's really helpful if you're just struggling with memorizing this formula. It's easier to think of it in terms of triangles and use the formula that he presents. So it's a good thing to just watch really quickly. I think it's like 3 minutes long, so it's worth your time just to see if that kind of clicks in your head more. This obviously is the same formula, just written a different way. So I'm going to talk about this one, and then if you want to watch that, you can watch that version, use that version. Either one is fine. You get the same answer either way, so whichever one makes more sense to you. You do need to know this vocabulary word, though, because you will, even if you don't use this version of the formula, you need to know what an apothem is. That you will run into that, and you will run into this formula second semester, so you need to know how to use this. Apothem is really just the height of the triangle. So it's just a fancy word for the height of a triangle inside of a polygon. So that's what it is. And then if you follow this formula, it's 1/2 times that apothem, so whatever this length is from the center of the triangle down. Now the key is to know that it's perpendicular. One common mistake is to use this, oh sorry, I didn't mean to move that, is to use this black side, which is actually the radius of the polygon. If you inscribed it inside of a circle, if you pictured a circle around here, this would be the radius of the circle, or we call it a radius of the polygon. Do not use that, okay? You must use, for the apothem, you have to remember that it goes from the center of the polygon straight to one of its sides, but it has to be perpendicular. Okay, so that's a key thing to remember. Don't accidentally use the radius of the polygon. Okay, and then the P stands for the perimeter. So for example, here we have 1, 2, 3, 4, 5, 6, 7, 8 sides. So we would multiply B times 8 to get the perimeter, whatever this number for B is. Okay, so let's try one of these. It says, what is the perimeter of the regular octagon? So the perimeter isn't too hard to find. They do tell us that one of the sides is 14. One thing I did forget to mention is that this only works, the formula here only works for regular polygons. So remember, regular means that all of the angles are equal. So this angle, this angle, this angle, all the way around, all those are the same, and all the sides are the same. So all of these 8 sides would be the same here. And since this is another octagon, I guess we're just like octagons today, all of these 8 sides are the same. So even though they tell you only one side is 14, because of this word regular, all of the outside sides are 14. So if we want to find the perimeter, remember perimeter is just, the distance around the outside. You're just going to take the 14, and since we know it's an octagon, we know it has 8 sides, we're just going to multiply the 14 times the 8, and that's going to give us 112. And so D is our perimeter. Question 2, find the area of the regular octagon. Well, now we need to use that formula, 1/2 apothem times perimeter. So remember, you use this formula if you're trying to find the area of a regular polygon. Now remember, polygon means 3 or more sides. So you could even use this to find the area of a triangle. It would work. You probably, as long as you knew it was a regular triangle where all 3 sides and all 3 angles were the same. In other words, an equilateral triangle. Although you can just use 1/2 base times height, which is the typical one that we use for a triangle. But it would work on any regular polygon, so any side, any shape, 3 or more sides where you know it's a regular, polygon. This is going to work on that. So I'm going to take 1/2. Now I want to double check and make sure that I have my apothem. Remember, the apothem is from the center of the shape straight down to one of the sides, and you must know that there's a right angle here. Okay? So we do know that. Now, just as a side note, well, let's finish this, and then I'll show you something. Okay? So the apothem is this 16.9. That's lowercase a. We call that apothem. We're going to multiply it by 1/2. And then we've already calculated our perimeter up above, 112. And so that's what's going to go in for capital P right there. That's what that stands for, is perimeter. Okay? And so if you multiply this out, you can just take 1/2 of 16.9, or just take 16.9 divided by 2, and then multiply that number by 112. And you should get 946.4. Remember, for area, that it's always your units squared. Any area at all, because area is 2-dimensional, so it's always squared. Okay? Now, what I was going to mention, let me switch colors here. Let's say, for example, that they did not give you this. Let's say we had to find it. Well, one thing you can do is you can draw a triangle. Okay? We know this is a right angle, so this is a right angle. So what I really have here is a little right triangle. I do know that this is 14 centimeters. And so this side over here is 14 centimeters. Because this is a regular polygon, and it comes from a property of an equilateral triangle, if I draw this side here, we know these two sides are the same because they're both radii of the polygon, or radius of the circle, if you inscribed it in a circle. And we know they're the same. And so one property of an isosceles triangle, which is, this triangle that we have here is isosceles, is that if you drop down this perpendicular line, both of these sides down here are equal. And so if I know the whole thing is 14, I know each of these are 7. And so sometimes what they'll do, instead of giving you the apothem, which is this black line down the middle, they'll give you the radius of the octagon or hexagon. So let's say they had given you, this is maybe 20 or something. Well then, because you have a right angle, or a right triangle, then you can use Pythagorean theorem to find your apothem. So just watch out for that, because sometimes, and that's the trick, is you'll see this line and you'll think, oh, that's my apothem. When just, be careful to double check, take a second to look at it carefully and make sure it's your apothem. If not, you can still find the apothem. You just have to use Pythagorean theorem to get there. All right, let's try another one. Here we want to find the area of the regular pentagon. So we do know that it's regular. That's one key thing that we need to know in order to be able to use 1/2 apothem times perimeter. But we can use that. So here's the formula. Okay, and so we can find all of this stuff. We'll just plug it all in at once. So the apothem is given to us from the center of the pentagon straight to one of the sides of the pentagon to where this is a right angle. So 5.5 is my apothem. And then my perimeter, I'm going to find that by taking one of the sides, which is 8, and multiplying it by 5, because a pentagon has 5 sides. And so you'll get 40 in there. So again, we can do 1/2 of 5.5, so 2.75. And then 8 times 5 is 40, so we can do that part in the parentheses first. Follow your... Please excuse my dear Aunt Sally. So in other words, all I did here was I took 5.5, divided it by 2. Okay, so that's where the 2.75 is coming from. The 40 is coming from 8 times 5. And now I can take 2.75 and multiply it by 40, and I get 110. And because it's area, we want to do centimeters squared. So A is your answer. All right, distance formula is something else we're going to cover. I already actually made this YouTube. This is one that I did for Study Island. We covered quite a bit of the distance formula, and you may have already watched that, but if you haven't, you can check that out. But you're going to use this ugly formula, and all it does is it's just a formula to calculate the distance between 2 points. So if you wanted to know what's the distance between B and A, the way the crows fly, this formula would do that for you. If you wanted to find the distance between C and A. Now, if you want to find the distance between C and D, you don't have to use this. This definitely will work. But the distance between C and D is a straight distance, a perpendicular distance, and so you can just count. 1, 2, 3, 4, 5. A and D would be the same thing. Now you can, like I said, you can use this. It'll give you 5 as the distance between C and D, but don't make it any harder on yourself. When you have to use it though is if you look from A to C, that's going diagonally across the grid, and so you have to use the distance formula. So let's try one. We want to find the distance between points A and C. Oh, I guess it would help if we had our picture on the screen, huh? There we go. All right, so we're going to take this formula and plug everything in. Let's get this over so we can see it all. So the x sub 2 and the x sub 1, this formula always scares students. It looks very ugly. It's not as bad as you think, although you do have to be careful with your signs. It's a tedious formula. You have to watch carefully that you don't mess up a sign. But the x2 and the x sub 1 just stand for the x values. Okay? And it does not matter which one you start with. If you start with 2 or -4 or -4 and then 2, doesn't matter. I'm going to start with 2 just to show you one place where you might make a mistake. In the formula, there's already a minus sign. So when you plug in this x value, it is a -4. So make sure you put -4. 2 minus a -4. So you're going to have, a double negative right there. Okay, so just watch that. That is one place to get messed up. However, when you come to the y's, you do have to think back over here and think, okay, which point did I start with? Was it A or C? So remember, this value of 2 came from C, so I want to start with that y value when I get to y2, y1. So I'm going to go 1 minus -4. My y value is again -4, and then I'm going to square that. Okay. Now, you just follow, please excuse my dear Aunt Sally. So you always do what's inside the parentheses first. So 2 minus -4 really means that you have 2 plus 4. Double negative really is plus. And so this is going to be 6 squared plus 5 squared, because the same thing happens over here. And then you square. So please excuse parentheses and then exponents. So now I'm going to do my exponents. 6 squared is 36, 5 squared is 25. And then I add. So 36 and 25 would give me 61. And then if you notice over here, we don't see the square root of 61 as our answer. We see it in decimal form. So go ahead and plug that into your calculator. Take the square root of 61 and you get 7.81, which rounded would just be the 7.8. So D. Okay. All right. 2. Find the distance between points B and D. Okay, so we're going to do B and D, and notice we have to use this formula because we do not have, put it down here again, we do not, it's not a straight distance, it's a diagonal distance. So let's practice another one. We're going to do x sub 2 minus x sub 1, which are just the x values. So let's say we pick, this is x sub 1, y sub 1, x sub 2, y sub 2. You could also do the other way around. This could be x sub 2, y sub 2, and this x sub 1, y sub 1. Doesn't matter. Your in-between steps here will look different, but your final result will be the same. Okay? So x sub 2 is 2 minus x sub 1, a -2. So I have a double negative again there. Y sub 2 minus y sub 1 would be -4 minus 5. Then I simplify in the parentheses. This is really plus, so 4 squared plus negative 9 squared. Then I square, so I get 16 plus 81. This is the square root of 97. And again, if you look at your answers, they are in decimal form. So stick square root of 97 in your calculator, and if you round it to the tenths, you get 9.8. And then units. We don't have feet or inches, so we just say units. Okay, choose the word that completes this sentence. This is from your 5.11 quiz. Triangle RS2 with vertices -3, -1, 0, 3, and 3, 0 is a right triangle, equilateral, isosceles, scalene. So this kind of combines, some previous information in Unit 5. You have to think about, okay, what do all these mean? Well, equilateral means that the sides and the angles are all the same. Isosceles means that you have two sides and two angles that are the same. Scalene means all three sides and all three angles are different. A right triangle, you don't necessarily know, it could be a combination of isosceles or scalene as far as the sides, but you do know that it has one right angle. So the first thing I would do is to just plot these points and just look at it. So -3, -1 is R, 0, 3, S, 3, 0 is T. Okay, so let's see what we think. Just eyeball it. Okay. And you might say, I think RT and RS look like they're maybe about the same, so I'm going to pick isosceles. I wouldn't do that. The distance formula is on this page for a reason. You're going to have to use it. And you're going to have to use it 3 times. So you're going to get a lot of practice with the distance formula. But you're just going to find the distance of RS, and then ST. I'll leave myself a little room so we can do that, and then RT. Okay, so let's get going. We'll do this 3 times. So the distance of RS would be the square root of, and I'll just say this is my x1 and y1. So I'll start with R. So -3 minus, and don't do -3 minus -1. Remember, it's x1 or x2 minus x1. You could say x1 minus x2 as well. The x2 and the x1, the main thing is just remember you want to subtract the x values. So that's what this means. So you're going to do -3 minus 0 squared plus -1 minus 3 squared. Okay, and then -3 minus 0 is -3. -1 minus 3, -4. And then -3 squared is 9, positive 9, plus 16. So this is the square root of 25, which is 5. Okay, so we found out that this side is 5. Okay, ST now. Square root of 0 minus 3 squared. So again, I'm doing the x1, or x2, I guess would be what I'm calling S, and x sub 1. So this 3 is not coming from here. It's x sub 2 minus x sub 1. Okay, now I'm going to do y sub 2 minus y sub 1. So 3 minus 0. Okay, so we're going to get -3 squared plus 3 squared, which would be 9, square root of 9 plus 9, square root of 18. And if you'd like to, if you don't like the square root, you can also change it to decimal. So this is approximately 4.2. Okay, so over here, 4.2. Okay, now RT. Okay, so R, I'll start with R. So I'll do negative 3 minus the x value of t, which is 3. And then I'm going to do the y value for r minus the y value for t. So I'm going to get negative 3 minus 3, negative 6. Negative 1 minus 0 is negative 1. I'm going to get negative 6 squared, which is 36. 1 squared is 1. Square root of 37. And you can probably figure out by now, I don't even have to, get the decimal for this, that it's going to be different than the other two that we've found so far. This does give you approximately 6.1. So if you looked at that, all the sides are different, that is scalene. So if you guess, as I say, it kind of looks isosceles a little bit, but once you actually calculate it out, it is not isosceles. All right, some extra credit for you. And again, to get this link, you will have to check out the PowerPoint and doc sharing. To copy and paste that link, I don't think it'll let you do it from the recording. But go ahead and take that online quiz if you want 5 extra credit points, and then copy and paste. It'll give you a score like this. Hopefully you do better than 0%. But copy and paste that in for extra credit. Good luck this week. Have a Merry Christmas, and let us know if you have questions.